All right. Well, Swartz has tried to convince you of regularity theory, of its advantages, and of the problems with the alternative, the necessitarian account of laws of nature. But there are problems with regularity theory, which is why it's still controversial. That's what the laws of nature are. So here are some of those problems. So here's another statement of regularity theory. It's basically like Swartz's. It has one slightly different item on there, which is an important addition, right, to Swartz's version, but it also has distinct problems as well. So call this naive regularity theory, right? P is a statement of a law of nature. P was just some proposition, right? Force equals mass times acceleration or whatever. So we have, any proposition counts as a law of nature if and only if, number one, it's universally quantified. This was in Swartz's account, right? It's got the format of for all x, if x is an f, then x is a g. It should be true, and again, true for all time and everywhere, not just locally. It should be contingent, right? It's not a mathematical truth or a conceptual truth like all bachelors are married or unmarried. um, and for, and this is sort of the new one, is slightly different than Swartz's version. P contains only non-local empirical predicates apart from logical connectives and quantifiers. So why non-local? We'll get to that. But this is basically the same as Swartz's account, right? This is what a regularity law of nature is. So basically what you get from these four conditions is that any true non-local generalization about matters of fact will be a law. So again, any true generalization that holds throughout the universe, right, is going to be a law of nature. So if it turns out that all swans are white, then it will be a law of nature that all swans are white. Now, right off the bat, a problem with that is this law, and this was something Swartz complained about, this law doesn't explain much, right? It doesn't tell us anything about the genetics factors that might explain the regularity. The law just is the regularity. So the local issue, right? Why stipulate that the predicates involved? Predicates is just sort of the properties picked out. So like, is a swan, is white. Um, Regularity theorist has to stipulate that they're not local predicates. So the point of this is that it shouldn't end up being a law of nature that everyone in this room is shorter than 6'4", right? That's just accidental. As it turns out, I'm the only person in the room. I'm 5'10", right? Um, that's a fact about this people in this room, but no one would want to say that's a law of nature, right? Why? Because we want laws of nature to hold throughout the whole universe, right? So this restricts the kinds of properties, the kind of predicates we could use in our laws. So living in Australia, no, that can't be in a law of nature. We can't have a law of nature just about stuff in Australia. Um, or a law about things that are 1 light second distant from a particular proton. Again, too local, too specific. Now, we could have laws about things that are 1 light second distant from any proton, right? That would be fine. That's general. But we can't pick out specific places, and we already stipulated no specific names either, right? We want the laws to be entirely general, and so that's what that stipulation is about. But the problem is, even with those stipulations, you can still generate some weird laws of nature on that account, right? So I could still um, I can still produce a law that only applies to a single object, even if I can only use very general predicates, even if I can't use names and I can't use places or right predicates like this room or Australia. I can still do it, right? And it still ends up a weird law. So, for example, here's a law. All faculty members taller than 6'4" of a university philosophy department that offers metaphysics in the first of 2 summer sessions, but has not offered it in at least 2 years. So, I can keep adding entirely general predicates, right? Faculty member is totally general, taller than 6'4", totally general, and so on, right? But if you keep piling them together, it'll end up that there's only one thing that actually fits that description. In this case, it would be Rick Grush, a member of our philosophy department, right? If the description is detailed enough, using just general predicates, you can still make it pick out only one thing, right? So now, if I complete that generalization, right, and say everything that fits that description, typically wakes up after 11 a.m., right? If that happens to be true of Rick, if he's a late riser. Okay, then it becomes a law of nature, right? That basically Rick wakes up after 11 a.m. And there's no real general universal regularity being picked out there. It's just a fact about a guy. But the problem is that formulation, that regularity that I formulated there, it satisfies all those rules in the first slide or the second slide, right? So there has to be extra. They need to pack on some more stipulations, right? They already tried to stipulate out names and specific places, but even so, you can formulate laws that only apply to one person, and that's just not what we want out of a law of nature, right? We don't want laws of nature to just tell us particular facts about particular people. So, maybe they could pack on more rules, right? I suppose that's possible, right? But here's the general issue that's going on. It's not just local properties, it's not just names. The idea is we want laws of nature intuitively only to involve properties that carve nature at its joints. This is a phrase that often comes up in philosophy, science, and metaphysics. And the idea is there's certain types of properties that matter, that make a difference in nature, and other ones that don't. So being the tallest member of a philosophy department, right, doesn't carve nature at its joints. There's no interesting generalizations you can make about those things, right? Other things like atomic weight, right? Um, Charge, like for protons and neutrons, right? Those probably are really important properties that do carve nature at its joints. And right, the atomic weight of something or its charge makes a big important difference, and it's the kind of thing that we want to talk about in our laws of nature. Right? But that's just sort of an intuitive, distinction. How can we make that distinction rigorous, right? David Lewis attempts this, and we'll read Lewis's account of laws of nature in a bit. But something like that is going to be necessary to save a regularity theory, right? And Lewis's account is a sort of regularity theory, right? He's trying to save regularity theory in part by giving a rigorous definition of what counts as a sort of property you can use in a law of nature and what sorts you can't. So far, we don't have a knockdown case against regularity theory, right? But what we have is like a significant problem that needs to be sorted out, and it's an open question whether a regularity theorist can sort it out. But there are other problems for regularity theory. So again, right, a regularity is just a statement of what is. It doesn't say anything about things that haven't happened, right? So as it happens, right, there are no gold spheres with a volume greater than 1 cubic mile. So according to regularity theory, this would be a law of nature. It describes a regularity that we observe, right? Gold spheres, there's a certain limit, right, beyond which there are none, right? But it seems strange to say that that's a law of nature, that there could never be a gold sphere greater than 1 cubic mile, right? If right, all the countries of the world decided to get together and make that a project, we could probably do it, right? Um, so, right, laws of nature that describe the way things are right now are going to make it a law. They're going to make certain things laws just because by accident they haven't happened yet, right? And that doesn't seem to be what we mean by a law. Now contrast, right, this with the law that there are no spheres of uranium-235 with a volume greater than 1 cubic mile. That probably is a pretty good law of nature because it would explode, right, before you got that big, right? So there's a good reason for that, right? It's not just an accident that there's no spheres of uranium that large, right, compared to spheres of gold. So again, these rules that we had at the beginning of the lecture, they don't make that distinction, right? According to that regularity theory, the law that there are no giant spheres of gold is just as good a law as there are no giant spheres of uranium. But there's an important distinction there, right? That's not being made. So again, yeah, there's lots of things that just haven't happened yet, but you don't want to say that they're ruled out by laws of nature. They're just things that haven't happened, might happen later. So another example, right now I think there are albino ravens, but there's no like race of white ravens, right? That like reproduce and they're all white. Was that a law of nature that there could never be a race of white ravens? Well, no. I mean, evolution being the way it is, right? If you had some ravens occupying the North Pole, just in the way that polar bears evolved to be white, you could have ravens evolving to be white, right? All sorts of things are going to happen in the future with evolution. We don't know, right? but we don't want to make it a law of nature that they can never happen. That seems poorly false, right? So again, just describing what is doesn't seem to capture what we need laws of nature. Another problem, a distinct problem for regularity theories of laws of nature, kind of a tricky logic thing, but it's mentioned in the article, so I describe it. So one thing about this, right? So look at in the first line there, for all x, if fx, then gx. This is, according to regularity theory, the logical form of a law of nature. And it says something like, for everything in the world, if that thing is a swan, then that thing is white, right? So f would be is a swan, g would be is white. Something like that, right? They're general universals. But it's sort of a tricky thing of logic that I don't have the time to get into. But universal generalizations about things that don't exist come out vacuously true. So if I say, all unicorns are magical, that'll turn out true because there's no unicorns, right? It's vacuously true, is what we say. So that means that it's going to turn out to be a law of nature that all centaurs are good at philosophy. Why? Because there are no centaurs, right? And so any statements, any generalizations about them will be vacuously true. And that seems wrong for laws of nature. People even puzzle about it when they take logic classes as to why that's the case, right? I don't have time to explain it now. Certainly shouldn't, our laws of nature shouldn't be like that, hopefully. But even worse, right, even if you could swallow that, it will also turn out to be a law of nature that all centaurs are terrible at philosophy, right? Because again, vacuously true, because there's no centaurs. So now we have a contradictory law, right? One law that says all centaurs are great at philosophy, one law that says all centaurs are terrible at philosophy. And we certainly don't want that, right? Even if you could swallow that there are like laws about centaurs, you don't want contradictory laws of nature. So that's a problem. And this is a special problem because we actually would like to be able to make laws of nature about things that don't exist or haven't happened yet, right? That's part of the idea of science, is to predict things. So for example, it is a law of nature that all brakeless trains will cause accidents, right? Or in general, maybe it's a statistical law, but like, yeah, if you're running trains around without brakes, they're going to cause accidents. Now, we can know this sort of a priori from what we know about trains, right? We don't have to go out there and build brakeless trains, have them get into accidents to then decide, oh yeah, it's a general rule that brakeless trains will cause accidents, so we shouldn't build brakeless trains. No, right? You want to be able to sort of predict things and prevent the accidents in the first place by never building the stupid trains, right? Um, but according to regularity theory, again, it only describes. So things that don't exist, things that haven't happened yet, has really nothing to say about them. And that seems to be a problem as well. We would like to predict, and we can know things about things that don't exist yet. And this will actually end up being an issue for any law that involves a continuous function, right? So um, lots of laws of physics have functions, right, that involve numbers, involve real numbers, right? A real number is, a decimal, right? Um, So there's going to be laws about, force equals mass times acceleration, right? So for any value of mass, this is supposed to apply, but there's going to be some very specific mass that no object has ever actually had yet, right? So maybe there's never been an object in the world that is 1.30276899945 grams, right? Or if there have, keep going, right? Eventually, you'll get a real number that's so specific that no object has ever had that mass, right? In which case, according to regularity theory, Newton's law wouldn't apply to that object, right? But that's wrong, right? Again, they're supposed to be universal, so Newton's law should apply to all objects of all masses, even objects with masses that don't exist yet or haven't existed before, right? Um, Same, velocities, right? So many laws of nature involve real numbers, right? Um, of course, they're going to be governed by the laws of physics. Regularity theory can't really explain how that would be the case. Because again, it's just describing stuff that happens, regularities. Well, if we've never seen an object that's 1.302 blah, blah, blah grams, then how can we say we haven't observed any regularities yet? And that seems wrong. So this is that was kind of just a loose collection of objections to regularity theory. Um, they could be good paper topics. Again, I'd for your paper, I'd like you to sort of zoom in on something very specific. So maybe there's a particular objection that you think there's a good response to. That would be a great paper. Say, I'm going to defend regularity theory against one of these objections, right? In the next lecture, the next paper by Dretsky, he offers what I think is a much more sort of general, in principle problem for regularity theory, and a reason that you'll want to favor necessity theory that I think is a little just more like kind of captures the bigger picture a little better. This one was kind of more of a loose collection of. I'll see you then.